number 5 from the 2014 examination paper. So for 5a, we want to show that this Cartesian system can be transformed into this polar system, and then we want to prove that there is a limit cycle. And for part B, we have this complex iterative map, and we want to determine the fixed points of period 1. So for 5 part A, we convert to polars using this formula, RR dot equals x dot plus y dot. So we just substitute for x dot and y dot, and notice that we replace x squared plus y squared with r squared straight away, just to simplify the calculations. So x squared plus y squared is r squared. So RR dot becomes this expression here, and using simple algebra, that simplifies to this, that should be x squared over 2 there, and r dot then is equal to this expression, and you can see that this agrees with what was given in the exam question here. To find theta dot, we use r squared theta dot equals x y dot minus y x dot. Again, we replace the x squareds plus y squareds with r squareds to make the computations easier. So here is r squared theta dot. We simplify this, remembering that x is r cos theta and y is r sine theta. And here is our expression for theta dot. If we easy plot this function, you can easy plot this function, and this is what it looks like, and you'll see that theta dot is always negative from this simple picture here. So we can plot this with easy plot. On r equals 1, so if we put r equals 1 into the r dot, then r dot is minus r cos squared theta over 2, which is going to be negative, and on r is 1 over root 2, r dot is positive. So we get an annular region where the trajectories go inwards, so therefore there exists a limit cycle in the annular region. R is bigger than 1 over root 2, but less than 1. For part B, we want to determine fixed point at period 1 for this mapping. If you look in your notes, we can write En equals xn plus Iyn. We can split into real and imaginary parts, and here are the equations. So the first equation is the real part, and the second equation is the imaginary part. Again, we can use MATLAB to sketch these curves. We know that A is equal to 4 and B is equal to 0.15. So to substitute those values, again we can use EasyPlot to plot these curves, and then we can use the data cursor in MATLAB to determine these points here where the curves cross. And if you use the data cursor, you'll see that you get 3 fixed points. So these 3 fixed points are found approximately using the data cursor in MATLAB. And that concludes the solutions to question number 5.